Need to restore the classic FastMCP behavior where GET endpoints automatically become resources and resource templates. We'll show you how to customize route mapping to bring back the pre-280 semantic handling, where GET requests with path parameters become resource templates and all other gets become resources. You'll see exactly how to override the default tool conversion with just a few lines of code. From FastMCP, import FastMCP. From FastMCP, server, OpenAPI import RouteMap, MCP type. Hash restore pre-280 semantic mapping. Semantic maps equals. Hash GET requests with path parameters become resource templates. RouteMap methods equals get, pattern equals R, asterisk /, asterisk /, MCP type equals MCP type, resource template. Hash all other GET requests become resources. RouteMap methods equals get, pattern equals R, MCP type equals MCP type, resource. MCP equals FastMCP from OpenAPI. OpenAPI spec equals spec. Client equals client. Route maps equals semantic maps. This demonstrates a declarative routing strategy for API to MCP transformation. The pattern uses rule-based mapping to convert OpenAPI endpoints into semantically appropriate MCP components, rather than treating all endpoints uniformly. What makes this distinctive is its separation of routing logic from the core conversion process, allowing flexible adaptation without modifying the underlying parser. The approach works by processing routes through an ordered pipeline of pattern matching rules. Each rule combines HTTP method filtering, path pattern matching, and tag inspection to determine the optimal MCP component type for a given endpoint. This declarative system enables precise control over how different API operations are exposed to AI clients, while maintaining a clean separation between the routing configuration and the conversion implementation. This matters because it solves the one-size-fits-all limitation of automatic API conversions. Complex APIs often need different endpoint types exposed differently, some as tools, others as resources, based on their semantic role rather than technical implementation. The pattern provides this flexibility while keeping the configuration explicit and maintainable, making it ideal for production systems where generic auto-conversion would create an unusable, overloaded interface. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools from Python functions. It handles the conversion of your code into OpenAPI-compliant endpoints that AI models can invoke directly. Without this, you'd need to manually define API schemas and connection logic. From FastMCP, server, OpenAPI import RouteMap, MCP type. This imports RouteMap and MCP type from FastMCP's OpenAPI integration. These define how API endpoints map to MCP tool types, enabling precise control over request routing and semantic behavior. Hash restore pre-280 semantic mapping. Semantic maps equals. This defines custom route mapping rules to maintain backward compatibility with FastMCP versions before 2.8.0. The list will override default OpenAPI route type detection, ensuring legacy path parameter handling works as expected. Hash GET requests with path parameters become resource templates. RouteMap methods equals get, pattern equals R, asterisk /, asterisk /, MCP type equals MCP type, resource template. This route mapping handles get endpoints with path parameters by classifying them as resource templates. The regex pattern, // matches any URL containing curly braces, which is the standard OpenAPI notation for path parameters. This distinction enables proper semantic handling of parameterized versus static resource paths. Hash all other GET requests become resources. RouteMap, methods equals get, pattern equals R. MCP type equals MCP type resource. This is the fallback route mapping. It catches all remaining GET requests without path parameters, classifying them as resources in the MCP type system. Without this, unmatched GET endpoints would be ignored, creating gaps in the API coverage. Closes the semantic maps list definition. This square bracket terminates the array of RouteMap configurations, finalizing the custom routing rules that will override FastMCP's default OpenAPI semantic mapping behavior. MCP equals FastMCP from OpenAPI. This instantiates FastMCP from an OpenAPI specification, converting API endpoints into AI-callable tools. The factory method handles schema validation and tool registration automatically, eliminating manual mapping. It's the primary entry point for integrating existing APIs with FastMCP's tool system. OpenAPI spec equals spec. Passes the OpenAPI specification to FastMCP, defining all available endpoints, parameters, and schemas. This specification dictates how FastMCP translates HTTP routes into AI-callable tools, ensuring the generated interface matches your API's actual capabilities. Client equals client. This passes the HTTP client instance to FastMCP, enabling actual API requests. Without it, FastMCP would have no way to execute the routes it generates from the OpenAPI spec. The pattern mirrors dependency injection, keeping network operations configurable. RouteMaps equals semantic maps. This applies custom route mapping rules to restore pre-280 behavior. The semantic maps list overrides default FastMCP routing logic, ensuring backward compatibility by explicitly classifying GET endpoints with path parameters as resource template, and all other gets as resource. This closing parenthesis finalizes the FastMCP. From OpenAPI, call, instantiating the MCP server with the provided OpenAPI spec, client, and custom route mappings. It's the point where all configuration takes effect, creating the operational server instance ready to handle requests. Route mapping precision. The custom RouteMap patterns restore pre-280 semantic behavior, where path parameters transform GET endpoints into resource templates while preserving all other methods as tools. Regex patterns match first, so order your maps from most specific to most general to avoid shadowing critical routes. This approach gives you both backward compatibility and explicit control over component types.
The route that becomes invisible to the mapper gains visibility to every client.